What up?
Vocab time.
It is.
Solutions.
We've got
vocab.
this many words to go through. So let's
20
do it.
many.
This many.
First one. Unit's called solutions. So let's do a solutions first.
Always picture comes first. That's what pictures of solutions looks like.
Yep.
It's by definition homogeneous mixture.
Yes.
The solute goes into the solvent. Definition of a solution.
Yes. We will do solute, solvent next. Homogeneous is not one of our words. So let's just do that right now.
Well, as it's from like many units ago.
Homo means
The same.
same.
Genius means composition.
So same composition throughout.
Same composition mixture. Yeah.
There we go.
Solutions look like they're the same from the beginning to the end.
All right. So now in this particular picture, we're going to focus on just the solute. Solute, see that blue powder stuff? The solute is the part of the solution that is being dissolved.
gets dissolved.
It's dissolved?
Mm-hmm.
Next, same picture.
Solvent. Solvent, therefore, must be the thing that does the dissolving.
Yes.
So, yeah.
Again, just like we need to get product and reactant straight,
Solute, solvent.
Something
Especially
last
because
unit-
there's
yeah.
there's similar words. Sol
Yeah,
starts
they
as
are.
the root.
Yeah. So
But it's
we need to make
the root is in solution. Solute, solvent,
Solvent.
solution. You know, it's
There sure- And then a lot of our solutions are what we call aqueous, and all aqueous means is specifically water is our solvent. Specifically, it just as soon as you see that little AQ, I know it's dissolved in water.
And the AQ usually shows up in chemical equations to
Yes.
tell the chemist, okay, this
Just
chemical is dissolved in water. You don't want to add it raw because it might be too concentrated. Another
Sure.
vocabulary word for the reaction to go. Maybe
Right.
it needs water to
Right.
make it happen. So
And just like gas and solid and liquid, or their aqueous is a particular almost phase. If you will.
to say, yeah,
In that regard.
almost. Alloy, sweet rims, bruh.
Yeah.
It's a solution of two or more metals. As a matter of fact, most of the metals that we come into contact with every single day are actually alloys.
We've actually manipulated them so that they're stronger or more durable.
Just
or
like you
don't
get a suit
react.
tailored to fit, you can tailor an alloy to fit a specific job.
Right, titanium's super strong and light, so we can
Right.
put alloys of these.
And
So,
since most of the elements are actually metals, most of the metals that we come into contact with are actually alloys of those metals. So
Nice.
anyway, let's move on.
solubility. I use table G here. This is right off your reference table to talk about what solubility is, because this is how we actually measure it. And that's a piece of. They got a picture of it there, Monaco.
I know, but it's in the packet. It's like right near the front, which tells you it's that important.
Ooh, yeah. So solubility, literally, the measurable ability of a solute to dissolve.
Right.
Some dissolve better than others,
Mm-hmm.
especially at temperatures. And speaking of dissolving, Monaco, what that mean?
That means, well, there's a picture of some dissolving going on there. It looks like we'll put a little sugar into water or some white powder into water, anyways.
Mhm.
But dissolve means to be able to dissolve into the solvent. So technically, the molecules all separate when they touch the solvent and separate from a part, and they disappear into
Right.
the interstitial spaces
Right.
between the solvent molecules.
That's why we say take the phase.
And that's why we say taking the phase up. So the solid goes into the liquid and disappears into the liquid.
It's all liquid. You wouldn't know the difference.
Appears to be all
Right. Now, dissociate is another one. These two words are, again, similar, like solvent and solute and solvent. You need to know the difference. And now only ionics will do this dissociating,
Mm-hmm.
right? And the picture shows the Na and the Cl breaking apart.
Yes.
Okay, and that's the key, and that's the definition. So when the actual atoms break apart now, so first the molecules or compounds break apart, that's dissolving. And then if it further breaks down into the atoms, now it's dissociated, and that is forming an electrolyte.
So what is an electrolyte? Well, there it is in our lab where we lit up the light bulb with a liquid. Huh? It's any solute that dissolves in water and then dissociates. Those ions, positive and negative, are just like the terminals on an electrical outlet, positive and negative. They'll move through the water, allowing the water to conduct electricity. They're not creating electricity. They're just letting the water behave like a wire because they're positive and negative ions that can move around, and they're not molecules.
Yes, we will retouch on this again in Unit 9.
Many times.
Yes. Soluble. This is looks like one of the
Simulations.
one of the FETs we had to do. So soluble literally just means it's able to be dissolved, forming a homogeneous solution.
You know what I realized in doing this vocabulary? There's like 6 words, all with the same root word that start with salt.
Yeah, and so you need to really pay attention because there's some very nuanced definitions that just change a little bit on these words. So you really need to study and get these words straight so you do well on your quiz.
And then here's one that's got a salt in the middle of it.
Insoluble.
What's that mean? Well, insoluble is not able to dissolve in water. It's one of those English words where you put in front of it means not. So unable to be dissolved. Yeah.
It's a weird
It's a grammar thing. So operable versus inoperable.
Look at our definition. Unable
unable to be
not
dissolved.
enable, it's unable, right?
Yeah.
Well,
Forms
we're not
a
English
heterogeneous
teachers.
mixture.
We are so not English teachers. Why are we even doing vocabulary?
I know English, but I don't teach English.
Did we do that one or no? Do I got to go back?
Yeah, just to clarify, without all the laughter,
If I put sand in water, it's insoluble.
and it's heterogeneous mixture.
I can see two different things.
It's not a solution.
No. Now, saturated. This works out just like what you would think a saturated sponge was. We missed the beginning of this little GIF, and you'll see he's going to add some powder to the water, and he's going to add so much that eventually the liquid won't dissolve anymore, and there's a little bit more powder at the bottom.
Right.
See what he did? So he's going to dissolve it up. All of a sudden, the liquid is holding as much of that powder as it possibly could dissolve, and there's a little bit left over at the bottom. So that tells me all the liquid up on top of it is now saturated.
Yes. Dissolve the maximum. Mr. Milk's sponge in his sink over there is saturated with old coffee. Means it won't hold any more. And if you go and touch it, it'll start to squeak and leak out.
Ooh. Precipitate.
Precipitate. This is cool. Kind of a little picture, some doo-doo. This is sodium hydroxide and silver nitrate mixing. Easily done in my chem lab.
I actually used to do this reaction in a 1,000-gallon vessel at Kodak.
To make the, let's see, sodium nitrate, silver oxide. Silver oxide. Oh,
Silver oxide.
that's the brown color, huh?
Yeah, and I had to wring it out through a big centrifuge.
Did it smell like doo-doo?
It was terrible, but can you think about how much money there was in that silver nitrate tote that I had to bring in with a metal truck? And
Thousands of dollars. $100 of silver nitrate's like this much.
Yeah.
And he's talking giant.
So that just formed a precipitate.
It's the insoluble stuff that falls to the bottom, or it makes the solution cloudy. You're going to see this when we do our precipitations rules lab in this unit.
And that's why I put that solid or cloudy, because both count. If all of a sudden it clouds up and there's something that formed in there, it's just not falling to the bottom.
Don't get caught up on precipitate. It's not the same as the earth science precipitation. Root and word, it's the same. It's stuff falling from the top to the bottom.
Check that out, mister. Check that out.
That's sweet.
So now that is a super saturated solution. And if you add a seed crystal, I'll take everything that shouldn't be in solution
And it
out.
drops out. It's called crashing out.
Crashing out. And so that means is the solution is actually holding more than it should be able to at that temperature. And there's a way you can, sometimes you can just come up and just tap the side of that and it'll crash right out.
Let's finish up our
Let's concentrate.
here. Concentrations. Well, this is a GIF to show osmosis, but what osmosis works is it works on concentration. Things go from high concentration to low.
Living environment about this.
So concentration is just either low or high. It's a measurement of how much is in there.
Per volume. Right?
Yeah.
How
And
much
then we'll
stuff?
get into the actual measurements of those. So the amount of solute per solvent of solution. It's just a generic term to relate.
It should be
dilute
of
versus
solution, not or solution.
Yeah.
My bad. You see that? Did you hear that we fixed that?
5 to go.
Oh,
In 1 minute.
Got you.
Move it.
One's on the right are dilute, one's on the left are concentrated. Relative term, guys.
Yep.
More stuff on concentrated. This one's good, so let's do this one. Let's do this
Molarity.
one. This one
Molarity
we
is a
need.
calculation that we will get plenty familiar with if you're paying attention. It's given to you in an equation there, but it's the moles of solute per liters of solvent. It's a
Specific.
standard way to measure concentration.
We will do a little bit about parts per million. There's a little quick chart on some stuff that's basically all you really need to know is very little amounts, very dilute solutions. We got to use parts per million.
Right. Now, the other way to measure concentration is with percent. Okay, just like we do percent on your tests or whatever like that, you can do percent with mass or volume as
Letter
well.
B is percent by solution right there, and there's a little example.
It's
and
a
then-
ratio, solving the basic mass per volume in terms of percent. Again,
No,
we will
pause.
use
I gotta go. Pause. I gotta go.
percent composition.
Boiling point elevation, I can change it. The boiling point and freezing point by adding a solute. Got it? We out. Good seeing you guys.